All right, hello everyone. We're going to be going over section 5.3, which is the application of exponents, scientific notation. So we have three objectives here. We want to express numbers in scientific notation, we want to convert numbers in scientific notation to standard notation, and we want to use scientific notation in calculations. So objective one, we want to express numbers in scientific notation. Now, numbers in science are often extremely large or extremely small and often contain many zeros. So scientists often express these numbers using scientific notation, and this is just a way to shorten the same number, just in a different type of notation so that they don't have to write like 10, 20 zeros. So scientific notation is a number is written in scientific notation when it is expressed in the form of a times 10 to the power of n, where 1 is less than or equal to a, which is less than, or the absolute value of a, which is less than 10, and n is an integer. So by saying that n is an integer, that means that we can have positive or negative values of n. So keep that in mind for now. In scientific notation, there is always one non-zero digit to the left of the decimal point. So when you write out scientific notation, we have some examples here. So if we have 3.19 times 10 to the first power, that's like saying 3.19 times 10. So we get 31.9. We move that decimal place 1 to the right because we had 10. Now if we take 3.19 times 10 to the power of 2, that's like saying 3.19 times 100, where then we move our decimal place 2 places to the right to get 319. If we had 3.19 times 10 to the power of 3, it's like saying 3.19 times 1,000, which now we're going to move the decimal point 3 places to the right. So really, you're moving your decimal place however many places to the right, according to how many zeros are in your 10. So when 10, we have 1 0, we move our decimal place 1 to the right. And 100, we have 2 zeros, so we're going to move our decimal place 2 to the right. And in 1,000, we have 3 zeros, we'll move our decimal place 3 points to the right. This is the same thing as our exponent on 10. So when we have 10 to the power of 1, we move our decimal place 1 spot. We have 10 to the power of 2, we move our decimal place 2 places to the right. When we have 10 to the power of 3, we move our decimal place 3 places to the right. So now if we have a negative exponent, if we have 3.19 times 10 to the power of negative 1, this is like saying 3.19 times 0.1. So now we're moving our decimal place 1 to the left. Then we have 3.19 times 10 to the power of negative 2. That's like saying 3.19 times 0.01. Now we're moving our decimal place 2 places to the left. We're having 0.0319. Then lastly, if we have 3.19 times 10 to the power of negative 3 equal to 3.19 times 0.001, we move our decimal place 3 places, or decimal point 3 places to the left. So we get 0.00319. So our decimal point is also moving according to our exponent. With negative 1, we had our decimal place move 1 to the left, negative 2, 2 places to the left, negative 3, 3 places to the left. So whatever our exponent is on 10, that's going to be how many places our decimal moves, and then if it's positive, it moves to the right, and if it's negative, it moves to the left. And once again, we always want to say that there is always one non-zero digit to the left of the decimal point. So we're always going to have something like 3.19, 5.2, 2.853, something like that. You're always going to have one non-zero digit to the left of the decimal point, and you're just going to have one. So that number is going to be either 1, 2, 3, 4, 5, 6, 7, 8, or 9. All right, so a number in scientific notation is always written with the decimal point after the first non-zero digit and then multiplied by the appropriate power of 10. So for an example, 56,200 is going to be written as 5.62 times 10 to the 4, because 56,200 is equal to 5.62 times 10,000, where 10,000 is just written as 10 to the power of 4. So we get 5.62 times 10 to the power of 4. So in converting a positive number to scientific notation, step 1, we want to position the decimal point. We place a caret, the little up sign, to the right of the first non-zero digit where the decimal point will be placed. Step 2, we determine the numeral for the exponent. So to count the number of digits from the decimal point to the caret, this number gives the absolute value of the exponent of 10. And then step 3, we want to determine the sign for the exponent. Decide whether multiplying by 10 to the power of n should make the result of step 1 greater or less. So the exponent should be positive to make the results greater, and the exponent should be negative to make the results less. So for example 1, we want to write the numbers in scientific notation. So keeping these steps in mind. If we're writing these numbers in scientific notation for part A, we have 93 million. So we position our decimal point, we place a caret to the right of the first non-zero digit. In our case, 9 is going to be the first non-zero digit. So let's use a different color in this case. So our caret is going to go right there. We're going to place our decimal point between 9 and 3. Then we want to determine the numeral for the exponent. So count the number of digits from the decimal point to the caret. Our decimal point in this case is technically right here, our current decimal place. So we want to count. We're going 1, 2, 3, 4, 5, 6, 7. I don't know where that came from. So we had 6 zeros and a 3 that we had to skip over to get to where our decimal point should be. So now we want to determine whether multiplying by 10 to the power of n should make the result of step 1 greater or less. So an exponent will be positive to make results greater, and an exponent will be negative to make results less. If we're just writing 93 million in scientific notation, this means that when we write 9.3, we're going to make 9.3 bigger. So this means that we need to have a positive value of n, and we counted 7 spaces, or 7 places from our decimal point. So we have 9.3 times 10 to the power of positive 7. Now for part B, we have 0.00462. We want to put our caret after the first non-zero digit, and this is where we place our decimal point. So our first non-zero digit in this case is 4. So we're going to place our decimal point or our caret right after 4. So we're going to place our decimal point here. Then we want to determine the numeral for the exponent. So count the number of digits from the decimal point to the caret. So in this case, we're going 1, 2, 3. So we've counted 3. And here we can write 7, 3. So we've counted 3 spots. And step 3, determine the sign of the exponent. We write out our decimal for the first part of our scientific notation as 4.62. Now our number is actually 0.00462, so our exponent is going to have to be negative to make 4.62 smaller. And since we counted 3 digits in between our decimal point and our caret, this will give us 10 to the power of negative 3. So the rule of thumb here is that if your number is very large, you're going to give a positive exponent. If your number is a decimal point, then you're going to have a negative exponent. So those are the main differences there. We see that large numbers are written with a positive exponent and small numbers are written with negative exponents. So exactly what we said before. Now objective 2. We want to convert numbers in scientific notation to standard notation. So multiplying a positive number by a positive power of 10 will make the number greater. Multiplying by a negative power of 10 will make the number less. So we refer to a number such as 425 as the standard notation of 4.25 times 10 to the power of 2. So whatever the actual number is, so in the back or in the our last example, where we had 93 million, 93 million is written in standard notation. It's the actual representation of the number, where scientific notation is written as our decimal times 10 to some power. So if we want to write the number in standard form, where we have something like 6.283 times 10 to the power of 5, we know where our decimal point is already. We know this is like saying 6.283 times 10 2, 3, 4. So 6.283 times 100,000. So really what we're doing is we're taking our decimal point. Since 5 is positive, we're moving our decimal point 5 spaces to the right. So we're taking 6.283. And we don't have 5 places to the right. We only have 3. We can see that we can move our decimal point 1, 2, 3, but then there's no other numbers. Well, since it's a decimal, we can add as many zeros as we want to it. So we can give it 2 more zeros to give it 2 more places for our decimal point to move. And this is going to give us 628300, which is going to be 628,300. So that would be our answer in standard notation. So when you're going from scientific notation to standard notation, you're going from this number times 10 to an exponent, and you're turning it into some really small number in a decimal, or you're turning it into a very large number. From standard notation to scientific notation, you're taking these large or small numbers and you're rewriting them to be in the form of some number times 10 to an exponent. The exponent tells us the number of places and the direction in which the decimal point is moved. So that exponent is very important. It's going to tell us the number of places we're moving and the direction. So positive exponent tells us to the right, a negative exponent tells us to the left. Then objective 3, we want to use scientific notation in a calculation. So example 3, we want to perform the calculation and write answers in standard and scientific notation. So we're going to use some of the rules that we've learned in our last sections, and we're going to use our scientific notation. So 4 times 10 to the negative 4th divided by 2 times 10 to the power of 2. We could definitely write them into their standard notations and calculate that way, but we can also use our rules from our last section in this section to find the value. Since they're being multiplied, we can separate 4 divided by 2 times 10 to the power of negative 4 divided by 10 to the power of 2. So in this case, we can use our quotient rule with 10. Since we have 10 to the power of negative 4 divided by 10 to the power of negative 2, we want to use our quotient rule. We can divide 4 by 2 normally. So 4 divided by 2 is just going to be 2. And then we have 10 to the power of negative 4 minus 2. Where negative 4 minus 2 is going to give us 10 to the power of negative 6. So this is in our scientific notation. But we also want our answer in standard notation. So this means that if we have 2.0, we are now going to move our decimal place 6 places to the left. So we want to fill in those zeros again. Because if we have 2.0 and we're moving 6 places to the left, we're going to take this point, we're going to go 1, 2, 3, 4, 5, 6, and then our decimal point is going to go there. And for all those spaces, we're just going to fill in our zeros. So it's the same thing as saying 0.000002. And this is standard notation. So that is how you would go ahead and use calculations with standard and scientific notation. So all right, that wraps up our section 5.3. So I'll see you all again in the next section.